This time, we are asked to prove that if the product of u and b is equal to b, then u is just equal to 1 for all u and b element of real numbers, given that b is also not equal to 0. This is another video for the review of real numbers, specifically on algebraic properties of R, as these important concepts are needed for understanding some concepts later on in real analysis, especially as part of it is on coming up with a proof on this statement. So this, even if this is too obvious for some, but for students for real analysis, we need to really show the proof of this, specifically with the use of algebraic properties of R. Let's start with the proof here. Okay, so we are going to assume, of course, let u and b element of real numbers with b not equal to 0 as part of the statement. And with that now, since we have assumed that they are both real numbers, that I'm talking about u and b, then we can use the algebraic properties of R. So we are going to have here, then we are going to start with the left hand side here, u is equal to, and later on hopefully will yield to 1. Take note that we have an hypothesized equivalence here. That will be part of our proof later. So how should we start this? In the previous video, we used the additive identity or identity element for addition, because that's for addition. In this case, we're talking about multiplication. So why not use here 1 as the multiplicative identity? And it's because u times 1 is just equal to u, since 1 is a multiplicative identity. The reason for that is, of course, 1 as the multiplicative identity can also be represented as a product of two multiplicative inverses. And that is where we are going to introduce some of the concepts leading to our goal later. Okay, I'm talking about this because we have a variable b here, and since b is not yet part of our proof, this is where we're going to introduce that b times b times 1 over b. These two are multiplicative inverse of the other, and if they are multiplied, definitely they will result to 1. So they are just equal to 1, hence we are not changing the value of the left hand side u, as we started with u times 1 earlier. The reason for that is this. Since we have the hypothesized equivalence as to the product of u and b, you can see u and b at this point here. But how can we regroup them? This is when we are going to use another property of multiplication, that is associative property of multiplication, thereby regrouping the terms. So instead of this group, I will have here the group of u times b, regrouping the first and second terms, and leaving, you have here 1 over b here. Okay? Now, 1 is yet to be seen, but we can see that this has already an hypothesized value of b earlier. This time, we can now substitute that here, b times 1 over b. Of course, this is okay because b is assumed to be not equal to 0 here. So when you look at the last portion of this proof, we can see a product again of two inverses, specifically multiplicative inverses, b and 1 over b. And when you multiply them, that's of course equal to 1. We can now see that this left-hand side u pertaining to this is equal to 1, which is also corresponds to this. Hence, we have satisfied the item we are trying to prove. And then, thus, we can now claim that u is equal to 1 as intended in our proof. And this is the end of our proof. Thank you very much for watching.